MCA Prep Packet Day 1. Benchmark 8114. This should be on page number 7 in your packet. Know and apply the properties of positive and negative integer exponents to generate equivalent numerical expressions. Number 1, simplify the expression 7 to the 3rd over 7 to the 5th in 2 ways. Part A, simplify the expression using a negative exponent. So using a negative exponent means that they want you to remember the property that we learned, where when you were dividing, as long as you had the same base, you could subtract the exponents. So 3 minus 5 is negative 2. So 7 to the 3rd divided by 7 to the 5th equals 7 to the negative 2nd. The second one says simplify the expression without using any exponents. So for this one, I am going to expand it. 7 to the 3rd over 7 to the 5th would look like this. And remember that when you see the same factor in the numerator and denominator, they cancel out because 7 divided by 7 would be 1. Now my entire numerator is gone, so what I need to do is put a 1 in to hold its place, because remember, if 7 divided by 7 is 1, I could make all of these 1s when I simplify. And then in the denominator, 7 times 7 is 7 to the 2nd power, or 49. So 1/49 would be our equivalent expression without any exponents at all. Our next benchmark is 8115, so that would be on the following page, page 9. Express approximations. So approximations means that we're rounding. Express approximations of very large and very small numbers using scientific notation. Understand how calculators display numbers that are in scientific notation. Multiply and divide numbers expressed in scientific notation, and express the answer in scientific notation using the correct number of significant digits when physical measurements are involved. Number 1, find the product 2.5 times 10 to the 3rd power times 6 times 10 to the 5th power. Part A, write the product in scientific notation, and part B, write the product in standard form. 2.5 times 10 to the 3rd power times 6 times 10 to the 5th power. Okay, so remember the commutative property says it's okay if we rearrange the order when we are multiplying. So I am going to do a little regrouping here so that I can multiply together 2.5 times 6 first. 6 times 5 is 30. 6 times 2 is 12, plus 3 is 15. So 15.0. And then remember that if we are multiplying the same base, 10 to the 3rd times 10 to the 5th, we can add together those exponents. If you wanted to look at it in expanded form to understand this, 10 to the 3rd times 10 to the 5th would mean that we have 8 tens multiplied together in all, so that would be the same as 10 to the 8th power. Now, the problem is my answer right now is not in scientific notation. It's not, because the decimal point is not in the correct spot. So I am going to take this decimal, it was times 10 to the 8th power, so I'm going to go to standard form first. 1, 2, 3, 4, 5, 6, 7, 8. Here's where my decimal point is in standard form. So I have 3, 6, 8 zeros. So here is my number in standard form, 1,500,000. Now, I want you to think about putting that decimal point in the correct spot for scientific notation. So here's where the decimal point is in standard form. I'd go back 1, 2, 3, 4, 5, 6, 7, 8, 9 places to get it to the correct spot. So 1.5 times 10 to the 9th power is my answer in scientific notation. So I multiplied together these decimal parts, I added my exponents, and then I had to make sure that my answer was still in scientific notation. The rule for scientific notation is that this decimal piece right here has to have only one digit before the decimal point, and that digit has to be from 1 to 9. So you cannot have a 0 in front of your decimal point, and you cannot have more than one digit. So something from 1 to 9. Our next benchmark is 8211. This should be on page 11 in your packet. Understand that a function is a relationship between an independent variable and a dependent variable, in which the value of the independent variable determines the value of the dependent variable. Use functional notation such as f of x to represent such relationships. So our rule for number 1, it says let f of x equal 4x plus 5. So the independent variable is x. X controls the value of the function. So what is the value at f of 12? F of 12. So notice that the x has been replaced with a 12. So you need to replace the other x with the 12 also. And then simplify. 4 times 12 is 48, plus 5 is 53. So the value, f of 12, is equal to 53. What is the value at f of negative 3? Same process. I'll start with my general rule, and then I substitute, because they want the value of the function when x is negative 3. So I replace both x's with negative 3. 4 times negative 3 is negative 12, plus 5 is negative 7. So f, the function at negative 3, equals negative 7. Our next benchmark is 8232. This should be on page 33 in your packet. Justify the steps in generating equivalent expressions by identifying the properties used, including the properties of algebra. Properties include the associative, commutative, and distributive laws and the order of operations, including grouping symbols. Part 1, use the expression, the quantity x plus y plus z. Part A, use the commutative property of addition to write an equivalent expression. The commutative property, remember the commutative property said a plus b equals b plus a. So we talked about it like changing the order. So maybe you remembered it by change the order of your addition. Maybe you remembered it by talking about communicating. A talks to B, and then B responds back to A. Or commuting, like commuting to work means you go from your home to your work, and then from work to home. So anything that could help you, communication, commuting, to remember that property, you should go with. So here is my original, and I need to change the order of two things to generate an equivalent expression. So I am going to change the order of the y and the x, like that. That's the commutative property. I also could have changed the order of, these, because it just depends on which addition symbol you're looking at. If you look at this addition symbol, changing the order of that addition, or this addition symbol, changing the order of that one. So either way, you're using the commutative property when you change the order of two things that are being added together. Now the associative property. The associative property, we said, is changing who you hang out with, who you associate with, change the group. Change the group. So the grouping symbol is what's going to move. So the order is not changing at all. So the order is still XYZ. The grouping symbol is what is going to move. So you move your parentheses from around the X and Y to around the Y and Z. So I would talk about X and Y, they're best friends hanging out. Well then, look what happens. Now Y is hanging out with Z. So in the parentheses, this piece has changed. The order does not change. Order does not change. You change your grouping symbol. Okay, our next benchmark, 8247. This is found on page 47 in your packet. Represent relationships in various contexts using systems of linear equations. Solve systems of linear equations in two variables, symbolically, graphically, and numerically. Symbolically means that you're writing it with symbols. Graphically, you're graphing and solving. Numerically, you could be using elimination or substitution. 8248, this benchmark is also included. Understand that a system of linear equations may have no solution, may have one solution, or an infinite number of solutions. Relate the number of solutions to pairs of lines that are intersecting, parallel, or identical. Those are very specifically the same words that we used when we taught chapter 6. So if there was no solution, your lines were parallel. If there was one solution, they were intersecting. And if there was an infinite number of solutions, the lines were identical. Check whether a pair of numbers satisfies a system of two linear equations and two unknowns by substituting the numbers in both equations. Because if it is a solution, it has to be true to both equations. Both equations to be a solution for the system. Number 1 says, consider the following three lines. So we have three different equations here. Part A says which two lines are parallel. And part B says which two lines intersect at the point 3, -2. I think the easiest thing to do on this problem is to graph the three lines. So that's what I'm going to do here. So I'm going to put a graph over here, and I'm going to graph all of these lines. My first one says 4x plus 3y minus 6 equals 0. I know that I need slope-intercept form in order to graph. I know that the m represents the slope of my line, or rise over run, and b represents my y-intercept, or my starting point. Okay, so this first line, I need to get the y by itself. So I am going to start out by subtracting 4x on both sides. So this is gone. Then I am also going to have to add the 6 on both sides because I want the y by itself. So now I have 3y equals -4x plus 6. The last step is to divide everything by 3. So now I have my slope-intercept equation, y equals -4/3 x plus 2. That means that my graph starts at 2 on the y-axis and goes down 4 over 3 to the right. Down 4 over 3 to the right. Down 4 over 3 to the right. I can reverse this. I could go up 4, back 3 to the left. And then I've covered my entire graph, which is a good idea because I really don't know where these are going to intersect with each other. So I might as well take a lot of space. Okay, so I'm done with this line. I can take, oh, I don't want to take that. Put that back. Nope, guess it's not going to work too. I was trying to shrink my writing here. There we go. Okay, so my second line, I can graph my second line in green. My second line is ready to graph. It starts out at 4. And then the slope is -2, so it goes down 2/1. So here's my second line. So you can see that these two lines intersect. They're not parallel, they're not perpendicular, but they are intersecting. And they intersect at 1, 2, 3, -2, 3, -2. So I have just found that lines 1 and 2 intersect at that point for part B. Now my third line I need to rewrite. So I need to subtract 4x. That will give me 2y minus 8 equals -4x plus 2. When I add 8, it does have a like term over here to add to. So 2y equals -4x plus 10, and then divide everything by 2. And I get y equals -2x plus 5. So if I start at 5, and I go down 2/1, down 2/1, what you should notice is this line is parallel to my green line, and it's right by it. It's actually right above that green line. So they've got the same slope, and when the lines have the same slope, they are parallel. So this line has a slope of -2 right here, and so does this line. So that makes them parallel. So my lines that are parallel for part A are going to be lines 2 and 3. So 2 and 3 are parallel, and 1 and 2 intersect at the point 3, -2. All right, that's it. So we are done with our MCA prep for day 1. So please finish all of those pages that we started, and we will correct them tomorrow.